Okay, pre-calculus chapter 11, section 11.1, real exponents. Thanks for joining us today. Chapter 11, exponential and logarithmic functions. Sounds so smart, so hard, really not that bad. Logarithmic, we've done logarithms before. Essentially, it's exponents and how to solve equations that have tricky and different exponents. So, just 1 point here in section number 1. So let's see if we can get that down. So chapter 11, section number 1. And see if I can type in, get there. See if I can type in another text box or not. Copy and paste it. All right, just 1 point. Evaluate expressions. We'll see how this goes. I'm going to try to type a lot of this rather than write it out with a marker. We'll do the marker for some problems, but I'm going to try to type a lot of it so that we can read it. Okay, just one definition. Here are two definitions, I should say. Properties of exponents. And then what is a rational exponent? Okay, so obviously we know what exponents are, but what gets a little tricky is then when you have a rational exponent. So essentially an exponent is a fraction and not just like a normal squared or something like that. There is a chart on page 696 of your book that was going to be a beautiful cutout that we were going to put underneath this property of exponent definition. So just take a look at that chart. Maybe you can jot in your notes since we won't have that chart. What is the product property? What is the power of a power property? Power of a quotient. So I'd probably just jot these titles in your book and then a quick summary. And you can pick what summary you want to use from the book there. But essentially, if we were all together, as we sometimes are, as we usually are, we would go over each of these and kind of just review product, property, power of a power, power of a quotient, power of a product, and quotient, and what that means. Essentially, you can see there in the book. Product, remember you add the exponents. So I'd probably jot in the definition part real quick next to each of those. Power of a power, multiply. Remember power of a quotient, distribute. Product, distribute. And then the quotient part, remember most of the time when you're dealing with the quotient power, as far as exponents are concerned, you can't really do a lot usually with canceling because of addition and subtraction. So typically you just stack them up as you need to, and then remember you have to write what would make it undefined. So in the example that they have, a cannot be 0. So essentially you have to label what x or your variable could not equal. So don't forget about that little part when you're dealing with the properties of exponent as far as with quotient. All right, we're figuring all this out here. All right, and then let's get the second definition here, rational exponent. So this rational exponent essentially said we can go back and forth, right, between either square root form or exponential form. So let's say, for instance, we had n root of b. Does that work? Oh, yes, there it is. All right, so if we had n root of b, essentially that equation, okay, or I should say that exponent, is the same thing, not as a limit, it's calculus, let's delete that guy until later, but we'll get there, equals, or is the same thing as b okay, we'll do it that way, to the 1/2 power. not quite written perfectly. But in other words, n root of b, the nth root of b, is the same thing as, did I say 1/2? We should have said n. Let's edit this guy. Can we edit it? Nope. Delete. Equals b to the 1 over n power. Let's try that. So essentially, remember the root, okay, if you can see my pointer here, the root is n as far as the index. Underneath the root, b to the first power, you then can rewrite in this form, b to the 1n power, right? So that is your exponent, b to the 1n. Quick example of this, let's go back to our numbers here, would be something like cube root of 27, right, is the same thing as 27 to the 1/3 power. Ooh, there it is. Let's try that. Superscript. There. Ooh. See, they don't like that superscript fraction. Too advanced for them. All right, so 27 to the 1/3 power. And of course, that all equals 3. So essentially, so you can put a slash in between here, semicolon here. But essentially, dotted craziness. So essentially, cube root of 27 is 27 to the 1/3 power, and that equals 3. Why does it equal 3? Let's try another. Where's my regular marker? There it is. So essentially, is that my regular marker? Draw freehand. Why is it dotted? 27 to the 1/3. Why is it dotted? Oh, there we go. Dotted until you let go. 27 to the 1/3, right? We say could equal 3 cubed to the 1/3. And then, of course, you distribute, power to a power multiply, so you get 3 to the 1st power. So that's essentially what our definition down here says. Cube root of 27, 27 to the 1/3 equals 3. Maybe a last bit of text you'd want to add down to this definition is that the denominator of the exponent always determines the root. Okay, so essentially, our example here is the cube root is 3, right? Cube root of 27. So that cube, that root, is always the denominator of your rational exponent. So 27 to the 1/3 means that's a cube root of 27 to the 1st power. All right, really we're just gonna look through some examples here in your book. So sometimes I'll just do these on the board, but rather than do that, since you can see the answers there, I might pick some other ones to do that are similar to that, just kind of explain them to you. But overall, nothing too terribly hard or crazy. Let's say we had 3 to the 4th power times 3 to the 7th power. Take advantage, or you take for granted how quick it is to write these on the board and how painstakingly laborious it is to write these on this computer. But what a great website. This is Wiseant, which I use sometimes to tutor children. But I think I figured out how to steal from their website and get free whiteboard access with numbers, because that's the tricky part. All right, let's spice it up here a little teal. So essentially, it's supposed to be an arrow. 3 to the 4th times 3 to the 7th over 3 to the 6th. Obviously all the same base. So what we're going to do first is obviously add the exponents. We're going to say 3 to the 4 plus 7 over 3 to the 6. So we obviously get 3 to the 11th over 3 to the 6th. And then remember our product property. This is from that chart that we started with. Hopefully, though, by now, you don't necessarily even need the chart because it's pretty much review. This was big 10th grade concept. our final answer. We subtract them, or we could think cancel them, and we get 3 to the 5th. Okay, and it's okay to leave your answer like that. You don't necessarily have to continue on and simplifying it. You can just say 3 to the 5th. All right, looking in your book there, I'm looking at example 2 and 3. Those are pretty straightforward. Distribute, cancel, right? You see example 3, letter B, you end up with x to the negative 9 times y, so you obviously have to flip it. Don't forget about that rule with negative exponents. But again, those are pretty straightforward. It's a little trickier over on page 697, where we have to start kind of evaluating with just numbers, essentially kind of number crunching. Let's try one of those. So let's say we had parentheses 27. Oh, fraction bar? No. Oh, parentheses, fraction bar. Do I have a normal? Oh, normal parentheses on the keyboard. I love that. 27 a to the 6th power. And all of this to the 1/3. As far as your notes, when we're doing these lessons and things, pretty much what I write down is kind of what I want you to write down. So we're obviously not going to have a ton. But kind of what we're writing down here is kind of how your notes should look like. Hopefully a little bit neater than my whiteboard scratch work. I don't have a mouse. I'm going to try to do a mouse in the future, but I'm using the trackpad today, and it is sketch. We're making it through. All right, go with brown. So rational, so that's to the 1/3 power, right? So 27a to the 6th to the 1/3 power. So first thing you want to do, it's been a long day. I'm knocking one of these out at the end. This is my first recorded lesson. You guys should feel lucky. This is GACS Fine Arts Day, Friday. Spent all day setting up Google Classrooms for every teacher in the entire school. And now I'm going to try one video so I can show them how to do it. Hopefully it turns out well. So far, not so great, but we're making it through. So 27 to the 1/3 times a to the 6/3, right? Because you are distributing that, both exponents. Obviously, we know from before, 27 to the 1/3, we could change that to 3 cubed to the 1/3, but essentially it is 3, right? What is the cube root of 27? And then here you just reduce the exponent. 6 over 3 gives you a squared. Final answer, 3a squared. Why was I thinking that one was tricky? Because it wasn't. Flip the page over, example 6 and 7. Evaluate there, example 6. You see letter B there, sometimes a little tricky. 16 to the 3/4 over 16 to the 1/4. Subtract them, the exponents, right? So 3/4 minus 1/4 is 2/4. So 3 to the half, or 4 to the half, 1/2. 16 to the 1/2. Let's look at that again. Let's try that again. Letter B, you subtract your exponents to get 16 to the 3/4 minus 1/4, which gives you 16 to the 1/2, or 2 over 4. Which then is square root of 16, or 4. All right, and then the last two, really just going back to our definition, you can write them with either rational exponents or with root form or radical form. So just don't forget your denominator is always your index and the exponent inside. Look at the example I'm looking at, example 7, page 698. Cube root of 64, s to the 9th, t to the 15th. Rewrite that, remember, as 3 as your base, 9 and 15 as your numerator, and then simplify. Okay, not too hard. We were going to actually take an extra day. There's just a lot of problems in this first section, as you'll see from your homework. But not nothing. Boy, it's a struggle. Not anything too tricky. Just lots of problems. I think this thing bumps me out of 15 minutes, so we are nearing the end. That is section 1 of chapter 11. Hopefully that wasn't too confusing and you can bust out some problems. Have a great day. We'll see you tomorrow.